All right, good day, everybody. This is Jason Strait with the Cloud Pass Virtual Group. Our presentation today is Azure SQL DevOps, simplified with production data. Our presenter is Paul Stanton, and before I hand things over to him, I'm just going to go through a few announcements. If you are not yet subscribed to the Cloud Pass Virtual Group, I do recommend going out and doing so at the cloud.pass.org website. On that page, there is a login to subscribe, and you can go in there and get logged in. And then once you're subscribed, you'll get made aware of presentations as they are coming up. And that's also a good way to find out if there are changes in the schedule, which we had a couple of back in July. Speaking of the schedule, we do have a number of sessions coming up over the next few weeks. Things that are covering DevOps from an SSIS perspective, looking at SQL-like query language with Azure IoT, SQL Server and AWS. So lots of different opportunities to go out and learn more about bringing your data into the cloud. If you are, though, interested in presenting, we are always looking for new presenters. I'm actually trying to fill up the presentation schedule between now and the end of March of 2020. So I'm trying to work on all of those slots. So if you are interested, please email us at cloud@pass.org. Or if you'd rather not write an email and you just want to fill out a form, I do have a form out at the cloud.pass.org website. Just click on the call for speakers and I can get your session set up. Coming this fall is PASS Summit 2019. The PASS Summit is pretty much the premier Microsoft data platform conference. These usually about 4,000 or 5,000 people that attend, and this fall there are over 200 community sessions that have now been scheduled and released for browsing. So do take a chance to go out and take a look at that. If you've not yet registered and are planning to, and I hope you do, you can get a discount on that registration using our virtual group discount code. That discount code there is there on the screen, VEGDISFKDQ, and it gets you that $150 off your registration. This virtual group is part of a number of virtual groups that PASS helps to support to help bring more data, knowledge, and learning into the community. If you are interested, there are virtual groups that focus on language, such as Global Chinese and Global Hebrew, and there's some that focus on job roles, such as database platform, database administration and business intelligence. So if you are looking for more training, please go and check those out. Throughout this session, you may have some questions. If you do, please type the questions in as you have them. Paul will be taking a few breaks here and there throughout his presentation to answer some of those questions to kind of keep them into the context of where we are at with the presentation. So please put them in as you come up with them. And with that, I'm going to hand things over now to Paul for his session today, Azure SQL DevOps, simplified with production data. And let me just expand, make you the presenter.
Thank you, Jason.
All right, there you go.
Hello, everyone. My name is Paul Stanton. I'm a co-founder at a company called Windocs. We're a group of former Microsoft engineers that have been focused on Docker SQL Server containers. And today we're going to talk about some new approaches to DevOps support that use production database cloning. I'm obviously going to talk about Windocs database cloning, but I want to point out that the same approaches that we're going to use today can be applied using Redgate SQL clone, and there are also PowerShell-based database cloning solutions out there as well. So we're going to use the Windocs software, but certainly is not an exclusive solution in this space. A bit about Windocs. As I mentioned, we're former Microsoft engineers. We launched an independent port of Docker to Windows back in 2016. We released and continue to support all editions of SQL Server 2008 onward. We also have introduced database cloning about the same time that Redgate launched a SQL clone. We're going to talk more about database clones in the context of DevOps. We also have added support for enterprise storage arrays. Pure Storage, Cohesity, NetApp, and others. These provide similar capability to what we're going to use today in the Windows virtual hard drives. And very soon we'll be releasing what we think is an industry first. Very excited to talk about what we call current snapshots. These are images that are built from a full backup that will be capable of being incrementally updated with differential and transaction log backups indefinitely. We're very excited about that. We think it'll be a great new option for people that are struggling with SQL Server refresh and database delivery processes. We also are releasing Kubernetes support. We have a press release going out tomorrow, and there's just a whole bunch of things going on, audit and reporting on these database operations. So we've morphed a bit from being purely a cloud native Docker container focused company. Now we are really addressing a broader range of modernization needs, database refresh and delivery with built-in cloud native support. Our focus today is going to be on the use of production database clones with SQL Server in the context of DevOps. The common alternative is that people are building development databases from source, and that does involve some work to work with test data. So tests have to deal with stubbed data. Now, we think that the availability of secure production database clones, where a single VM can support up to 50 containers and complex cloned environments that may be comprised of several databases, they may be terabytes in size, but those can be delivered in a matter of seconds and occupy, on the order of 40 megabytes of storage. So they're essentially very fast, very efficient, faster, frankly, than building a dev database from source. We also think that the advantages of using production database clones in a DevOps context are pretty compelling insofar as performance and data-related issues will be surfaced more quickly than when working with a built database. And you have a more reliable DevOps process because you don't have to make changes. The full production database environment is basically being used from the get-go of the DevOps and continuous integration pipeline all the way through the development and test process. We'll also take a look at how Git is incorporated into this workflow. It's certainly by no means limited to Git, but that does seem to be the popular approach for source control today. And the bottom line is you're going to end up with a simpler, faster, more scalable, lower cost pipeline, we believe, with database clones. The process will, the process that we'll use involves, production database clones. As I mentioned, they can be sourced from storage systems or from backups. There's going to obviously be some form of source repo. We like to support people that are using migration scripts. Those are going to be incorporated into a workflow that uses SQL Server containers with database clones. And then that Azure DevOps pipeline, or it could be a Jenkins pipeline, is going to orchestrate and deliver these environments for development and test and staging pipelines. It's common for this environment to be today in a hybrid cloud environment and to interoperate with Azure hosted Kubernetes cluster where the .NET or .NET Core apps may reside. Other people are using this with OpenShift, and this also runs on a Azure IaaS VM as well. So it gives you the flexibility of running SQL Server where you choose and where it makes the most sense. The basic form of the pipeline is supported by a Docker file, which is nothing more than a plain text configuration file. In this case, you can see we're going to be working with a SQL Server 2017 container. The image is going to include a single customers database that is being built from a full backup of that database. We can copy and run SQL Server scripts on that database for data masking. And at runtime, you can see in this case, we're going to run a git clone, and we're actually going to pull a repo into the container. Now you'll also notice that we're going to run a PowerShell script that will order and concatenate migration scripts. And the PowerShell command is pretty simple. It's included down below, and really does nothing more than to put the migration scripts in order, because obviously a whole collection of migration scripts cannot be run without consideration of the order. And so, in a simple Git-based migration script strategy, this PowerShell script, the combined scripts.ps1, is going to be updated and pushed to the repo for every commit to the repo. So when a developer completes, an add column at create.sql script, it's going to be explicitly put into the order of application for this project. And this command, get content and set content, is just the PowerShell commands to concatenate and put those into an ordered script. So I'm going to pause here for a moment to see if there are any questions, Jason.
No questions yet.
Okay. Now the process that we're going to take a look at is from a command line perspective or from a web UI. We're going to build an image. That's in the lower right-hand box here. That is the Docker file. That image is going to be built on a VM that has SQL Server and has the access to the backups. And the process of building a image that includes database clones starts by building the target container environment. Earlier I showed a Docker file that was using 2017. This is referring to 2016, but that'll vary depending on what you're doing. And the process will identify where are the backups located that are going to be used in this process. A VHD, a fixed size VHD, will be built to accommodate the size of the databases that are being worked with. That VHD will be mounted to the container, and the backups will be restored to it. And on completion of that, any build time scripts are applied, such as data masking. Once that is complete, then the VHD is saved. The VHD is built in the same location as the backups, and that saved VHD then is used to create clones that are then served up. They're mounted to the SQL Server containers as part of the DevOps pipeline. So I'm going to switch gears here and let's take a look at how these things work. So what we have in front of us is Windocs includes a web UI. This simplifies the developer and tester experience. Underlying this is the Docker implementation, Docker APIs, and Docker command line. And you can see that we've built that image. In this case, the image is called clone. and it includes the customer's database. Now, a typical developer is going to generally work with a self-provisioned environment. So we'll make Jason our developer nominee for the moment. And Jason can assign a port to the target container. He can also assign a optional SA password if he wants. But in this case, we'll just deliver the container as it is. Now, so what's happening now is the SQL, like this is you can see we're working with a SQL 2017 environment, and that container is being spun up, and at the same time, the database clone image, the VHD, is being cloned. A differencing disk is being created. That differencing disk includes the customer's database. It includes the data masking script that was applied earlier at build time. And that database is going to be mounted to the container as the container is started. And this will take a total of 30 to 40 seconds. The process to accomplish this is no different if the image could include up to 30 or 40 or 50 or more databases. As I think our customers average, a half dozen databases in typical images. And it could be a multi-terabyte environment, and it would take no longer. And the database clone on delivery is going to occupy less than 40 megabytes. So I'm going to go ahead and start that container. And we've got demo problems today. So I'm going to switch gears here. I don't know why this is not starting, but we've got a running container here at port 10,014. So let's go ahead and take a look at that. I apologize. We're in the midst of a new release for that incremental update process I talked about earlier. And it's biting me on this test. So I'm going to use Windows authentication as one of the things that Windocs supports. One of the reasons we've been successful. And you can see that, we've delivered a container. It's at port 10,014. It has that customer's database. And if we actually wanted to roll into the container, we would see, we could go into the containers file system. We would see a scripts folder with the migration scripts included in that environment. So Jason, do you have any questions at this point?
Nope, no questions.
Okay. So that's the basic workflow of, including provisioning a SQL Server environment with a clone database. What I want to do now is I'm going to switch over to Azure DevOps. Now that VM that we just used is running on AWS. Now I'm going to work with that from an Azure DevOps pipeline perspective. This obviously is hosted by on Azure. And you can see that I've got a YAML file that includes a number of variables in the pipeline YAML. So you can see, I'm pointing to a particular VM. We're going to port 3000 because that web UI issues a secure token. It's a Node.js app, and that happens to be the port it's at. I've got some credentials that are going to allow me to provision the clone image. And you can also see that we've got the scripts that are being worked on in this pipeline are also included in the variables. And we can go ahead and we can kick off a new pipeline build. Now, this is commonly set up to be automated when a new commit is made to the repo. In this case, we're going to just run it manually. But what I want you to see in this process is that you know, the opportunity to simplify SQL Server DevOps by using database clones rather than working with built databases. Building the database is going to take longer than the 20 seconds it takes to clone and deliver a clone database environment. And, I would argue that database clones provide a higher fidelity, CI pipeline support. Again, there will be performance issues and data related issues that will be surfaced earlier in the pipeline than would otherwise be realized with a built database. Another point I would make is that database clones can be used throughout the pipeline without change. So again, I think it drives a more reliable continuous integration process simply because you're not moving from a dev built database to something that more closely approximates your production environment. So there should be some questions arising at this point. If there are no questions, we're going to end up finishing early. So do you have any questions in the queue at this point, Jason?
Not at this point, we don't.
Wow. Come on, folks. Make this time useful for you, because otherwise we're going to be done in a hurry. There must be some questions out there. Now, what's happening here is we've got a simple two-stage pipeline. You can see we're building a test environment where there's some unit tests being run, and then on completion of that, we'll proceed into a staging environment that's another SQL Server container with the identical environment, but with a different set of tests being applied. And so it's a very simple two-stage pipeline. We have the YAML for this available. Anyone wants to download it, email me or just visit our website and download it. And it's very straightforward to integrate this with .NET or other Node.js type front ends as part of a multi-tier pipeline. And that's what our customers are doing with these containers. I'll also just comment at this point, clearly SQL Server containers, are fast, they're efficient. You're using one VM instead of a whole group of VMs. So they're more economical. But the other advantage of containers is that I hope you can see is that you don't have any configuration drift. These containers are being provisioned, they're being tested, and if the tests pass, then they're being deleted. And there's just no need to keep containers around because it takes all of a minute to provision a new, fresh environment. It's taken us, how much time have we used here? So just over 3 minutes, we've gone through a two-stage pipeline build and test. We can access the container details here. We've got 2 containers for test and staging. And, we could access those and do further work if we chose to. And that is, the basic pitch for modernizing, a SQL Server DevOps pipeline with containers and database cloning. I don't have a lot more to add. If there are no questions, I think we'll wrap this up early.
Sure, and actually, I do have one question.
Sure.
So I was recently going through SQL Server 2019 release candidate 1, and I'd previously had an environment where I had set up some of the CTPs. How easy is it to kind of containerize that upgrade process so that you're minimizing the amount of effort that you put through?
Well, you're talking about upgrading from one release to the next?
Yeah.
Yeah, so it's a good question, Jason. If you go back to the Docker file, what you can do with that Docker file is you can you can specify, you build a container using MS SQL 2019,
Yep.
and you could be using backups from a SQL 2014 or 2016 environment. So it's really actually a very efficient way of testing upgrades is to build that database clone using your source database backups and apply them to your new target environment. Does that make sense?
Yeah, it makes perfect sense.
Yeah. So that's it's a small but important use case for containers with database cloning. It's just simply support for the upgrade and migration process.
Yeah, I mean, I can totally attest that while I was working on
Yeah.
the SQL Server 2019 and they were releasing new candidates, it was painful is the slight word.
Yeah. Yeah.
So we do actually have a few questions now.
Okay, good.
Um, how can this scale up to use? Can this scale up to use backups from Azure Data Warehouse?
Yeah, good question. We have customers that use backups from SQL Azure as well as Azure Data Warehouse, and those work very well. We have customers that essentially they're running their production workloads on SQL Azure. They'll set up a IaaS VM. They'll take the backups, drop them down. They'll build the images on that IaaS VM and go through exactly the same process that we're using today. So it works great, and it's a good use case. Another use case, just incidentally, is this is also being used to use SQL Azure databases as sources for SSRS containers. It's another use case that's growing in popularity. This works for AWS RDS, but also SQL Azure. Because we support SSRS containers and those services do not, it provides people a new option for a scalable SSRS solution on these public cloud services. What else do you have there, Jason?
Yeah, can you restore a local DB on the container?
Absolutely. Yeah, so the containers are simply a named instance on the host. So you can create databases, you can restore backups to the container. The SQL Server containers on Windocs are simply named instances. Incidentally, we create those containers by cloning a locally installed and licensed instance. So they have all the functionality of a named instance. You can restore to those containers if you wanted to. You can create new databases. You can run scripts, everything you do normally. It's just they're a pretty full-functioned environment, obviously.
Okay.
That's how we also support Windows Auth, which is an area where Microsoft has struggled with the new architecture that they've implemented.
Cool. Next question is can you do this? Can you basically spin up SSAS instances similar to relational? And do they use the same approach with the backups?
Yeah. So today, Windocs, we support the database engine. We support SSRS. We support linked servers within the database engine. We do not support SSAS today. That is on our roadmap. I expect it will be late this calendar year.
Okay. And how is Active Directory integration accomplished for SQL Server logins? Is this part of Windocs?
Yeah, as I mentioned earlier, Windocs creates containers by cloning a locally installed instance. And that container then is written to the registry. It is written to the WMI namespace. On delivery, it is indistinguishable from a conventionally installed SQL Server instance. And because of that, we have Active Directory and Windows Auth support. It's one of the key features that has allowed us to be successful is this ability to deliver containers that have the same SQL Server namespace isolation, support for encryption, support for third-party key managers, Active Directory, Windows Auth, networking support. So these containers give you all the benefits of Docker with fast environment creation, the combination of containers with database cloning in this image that we've taken a look at today. But at the same time, it does not break compatibility with SQL Server operations as you know them today. So this has been really important for us to be able to address the enterprise needs. People want to modernize, but they don't want to break or create what some would argue would be another technology silo. With Windocs, you get SQL Server containers that are fully compatible with your current infrastructure, and that includes Windows Auth and Active Directory and virtually everything else.
Right. And then does this in any way reduce the storage footprint of non-production environments?
Yeah, it's a great question. I love that one because it absolutely does. If you think about the process that we've taken a look at today, now I've not demonstrated this incremental update capability, but it's coming very soon, where you could build an image, you could update it daily with either differential or transaction log backups, and that image then can be cloned and delivered to SQL Server instances on the LAN or to containers and provide a more modern approach to database delivery and SQL Server refresh support. Each of those environments on delivery will require less than 40 megabytes, but they support read-write operations, and they perform really well. And so you think about the time and the effort involved in supporting backups and restores on a daily basis. This is a modern approach that delivers database clones. They're very lightweight, so there's huge storage savings, but also a lot of other benefits as well. Think about the benefits of consolidating instances with containers on a single host as one potential benefit, but you create a audit log of the images, the updates, the data usage. It's all auditable and reportable on the Windocs environment, and you improve security and data governance. So storage savings, compute savings, security and governance benefits. There's a lot of reasons why this is growing, in popularity.
All right. And then there was someone who asked a question that they're not really they're pretty familiar with SQL Server, but they're not with containers, and they're looking for kind of the general why would they choose to use a container?
Well, the primary place where containers shine is just as we've looked at today. In a continuous integration pipeline, you want to be able to deliver isolated but identical environments on demand. So we just looked at a process where containers deliver a complete complex database environment in a matter of seconds without configuration drift, without the costs of maintaining a VM. And those can be provisioned and deleted and provisioned again on demand to support an automated CI pipeline. So that's very clearly a more efficient, more reliable process than using VMs. Outside of the CI process I mentioned earlier, people are using SSRS containers for a scalable approach to reporting services on Azure for SQL Azure source databases. Again, containers can be created from an image, and they're more easily managed than a fleet of VMs or a fleet of VMs with fixed named instances. Just gives you a better, more scalable managed environment. The other use case, frankly, is that a lot of people are moving away from dev environments on workstations. Why are people spending time maintaining personal SQL Server environments on a workstation when they can be created on demand on a server? The move towards cloud native computing, where you have elastic scalability you just get more economy by running containers than you will with VMs. So our customers are reducing their VM count on the cloud by a factor of 5 to 1, where they had perhaps 100 different instances. They can use containers. They can run that 100 instances pretty easily on 5 to 8 container hosts.
All right,
So
excellent.
yeah, so it's a matter of economy. It's a matter of, do you want to automate? Um, those are, you know, those are where containers shine.
Right. And then another question that came in is there a restriction from a SQL Server perspective on versioning, such as Enterprise, or can you also use this with Express and other versions of SQL Server?
Yeah, Windows supports all editions, so Express all the way up to Enterprise works great. And because you're cloning a locally licensed environment, and because SQL Server licensing from Microsoft allows for additional named instances on a licensed host, you get to duplicate that enterprise environment or duplicate the dev environment as you need, as long as that host is properly licensed.
All right. Well, that is all the questions that we have right now. It doesn't look like any others are coming in. So,
All
Paul,
right.
thank you for presenting today. This has been actually really helpful for me. And it sounds like from the comments that a few folks have put in that it's been pretty helpful for them as well.
Yeah, very good.
So,
Now, yeah, so just to end by anyone that's interested or has further questions, feel free to email me directly. My email address is Paul S. That's Paul is in Stanton, Paul S at windocs.com. Happy to answer any questions, happy to follow up. Always happy to chat about this stuff.
all right, excellent. And thank you everyone for attending and hope to see everyone back at the next session. And good day, everyone.
Yep. Thanks, Jason.
Oh, you're welcome.